So when it comes for excluded, we cannot take them in count. When it comes to included, okay, the person should be included. You have to remove the person from N as well as R. So whenever you have the question like included, remove that person from the total as well as the selection. The two girls who won the prize last year should be included. So should be included. How many girls? Two girls here. Hello everyone, a warm welcome to one and all. So this is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysore. So welcome to the last session of permutations and combination. So in our previous session, we have discussed in detail about all the permutations and combinations and how we can arrange anything using permutations as well as combination. So in the previous session, we have discussed about some properties and geometrical formation of figures using combinations. So that is, while doing the combination, the very important thing is you have to remember all those properties. The proof is not there for your syllabus, but you have to remember all the properties and some important formulas for the geometrical figures. So we have studied the formation of straight lines, the formation of triangles, how many number of diagonals can be drawn inside a polygon, or how many sided polygon is there when number of certain diagonals are given. So these type of question and very simple problems we have solved in our last session. In this session, we will discuss about how the arrangements of people or any objects can be made when we have at least 3 members or at least 4 members, or when 2 members are included or 3 members are excluded. So these types of problems we are going to solve in this session. So let us start today. My first question is, in how many ways can 6 people chosen out of 10 people if one particular person is always included? So here my total number of people N is 10 and my R is 6. So we are supposed to choose 6 people out of 10 people. But my condition here is one particular person is always included. One particular should be there in the group. That means we are opted to select only 5 persons. So we have to select only 5 persons. So since out of 10 people, one is always included. That is, out of 6 people, one is always included. So he has been already in the group. So remaining is here 9 and here it is 5. So the selection must be made in 9C5. So remember, when you have the questions like included, so you have to minus the total number of person from the total number as well as from the selection. That is, from N and R, you have to subtract the number of persons who are included. So this is the hint for these type of question. So here I said we have to select 6 people out of 10 people. Since one person is always included, remove that one person from the total, that is N, also from the selection, that is R. So therefore here my total ways becomes, is 9C5. Okay, so you're almost been carrying the calculation for so many problems. So I'll just directly write the answer. What is 9C5? 9C5 is 126. So this is my answer for this question. Okay, so that is out of 10 people, I have to select 6 people where one person is included. So whenever you have the question like included, remove that person from the total as well as the selection. That is, you have to subtract the total number of person from N as well as R, and you should find the combination of only the remaining people. So for this question, my answer is 9C5. That is 126. So next question. In how many ways can 6 people chosen out of 12 people so that 2 particular person always included, two particular person always excluded. So remember the hint for the first question. I said whenever the person is included, you have to remove them from the total as well as the selection. So we have n here 12 and selection must be 6 people. Our R is 6 people. For the first question, so they have given 2 persons are included. Okay, so 2 persons are included. So you have to remove 2 from 12 as well as R. Okay, so therefore my selection for this question will be 10C4. Got it? Out of 12 people, 2 is already there, and also from the selection, 2 is already there. We have to choose only 4 persons since 2 people is already been there. So therefore, my selection will be 10C4. That is 10, 9, 8, 7 over 4 factorial, that is 4, 2, 3. I said 1 you can write or you can leave, okay, because the product will be same. So my total ways will be 210 ways for this question. Okay, so looking at question B, 2 particular person are always excluded. So when it comes for excluded, we cannot take them in count. So therefore, I have to leave 2 person. So here I have 12 person. 2 people cannot be in the group. So we are left with only 10 members. Okay, so out of 10 members, we have to choose 6 people. So here 6 like this, 10C6. Okay, so here also my total ways will be 210. So I leave the calculation part for you because I have already explained so many questions using calculations. So I'm just writing the answer. Okay, so therefore, whenever it comes for the excluding part, okay, you have to remove the total number of person from N only, not from R. Okay, only when it is excluded, you can remove the total number. So the total number changes and R remains the same. Okay, but in case of included, you have to remove the person even in N and also in R. But in case of excluding, only in N, you should remove the total number of persons. Next question. A team of 8 players must be chosen from 14 players. In how many ways a selection can be made if 2 particular person always included, 2 particular person always excluded? So I hope you understood now. When it comes to included, okay, the person should be included. You have to remove the person from N as well as R. So here my actual N is 14 and my actual R is 8. So since 2 person is always included, here my selection will be 12C6. Got it? 12C6. You have to remove the total number of person from N as well as R in case of included. Okay. So when it comes 2 persons excluded, so you are not supposed to take them in count. So therefore here 14 minus 2 will be 12. There will be only 12 players. Out of 12 players, we are supposed to select 8. So here my answer will be 12C8. Okay. So out of 12C8. So remember, whenever in the case of excluding and including, whatever I said. Okay. Next question. A team of conveners consisting of 4 lecturers, 4 boys and 2 girls has to be selected from 15 lecturers, 10 boys and 12 girls. In how many ways the selection can be made if the 2 lecturers who were conveners last year have to be included, 3 boys who failed in the examination cannot be chosen? So I'll just brief out this question. So we have how many lecturers? We have lecturers, boys and girls. Okay, how many lecturers we have in total? We have 15 lecturers and 10 boys and 12 girls. Okay, out of that, we are supposed to choose 4 lecturers, 4 boys and 2 girls. So this is what my actual question, and here is the condition. Here is the condition. What is that? 2 lecturers who were conveners last years have to be included. Okay, so here 2 lecturers must be included. Okay, 2 lecturers must be included. And one more thing, 3 boys who were failed in the examination cannot be chosen. Cannot be chosen means what? 3 boys must be excluded. So whenever the statement problem is given, study it properly. Okay, so therefore, let me solve the problem now. So here is my choice. In lecturers, 2 lecturers must be included. And also one more clue I have given. Remember, and means multiplication of combinations. So here, let me solve for the lecturers. So out of 15 lecturers, 4 lecturers must be chosen, whereas 2 lecturers will be included. So therefore, my choice for the selection of lecturers will be 13C2. I hope you understood why I have written 13 and why I have written 2. Whenever in case of included, remove the total person from N as well as R. And also boys. So boys, we have a condition for excluding. Okay, we have to remove 3 boys, because they cannot be chosen. So therefore, out of 10 boys, I have to remove 3 boys. So therefore, boys left is only 7. And how many boys I can choose? 4 boys I can choose. Then, and girls. So there is no condition for girls. So therefore, my selection is 12C2. Okay, so this is my formula, or this is how we simplify when there are more number of arrangements. Okay, so you should be very careful with and or letters. Then, so I'll just write the solution for it directly. So my 13C2 is 78, 7C4 is 35, and this is 66. So my answer is 1,80,180. Here is my next question. A committee of 4 has to be chosen from 10 boys and 8 girls. In how many ways this can be done if girls are in majority? So I have 10 boys and 8 girls. Out of 10 boys and 8 girls, a committee has to be formed. We can choose 4 members for the committee. 4 members may be girls, all 4 members may be boys, or 2 girls, 2 boys. But we have a condition here that girls are in a majority. Girls are in a majority means, suppose if I choose all the members of the committee are girls, no boys can be chosen. And suppose if I choose 3 girls, then 1 boy can be chosen. If I take 2 boys we can choose, but this is not possible. What is my question? Girls are in majority. That means what? The number of members in the committee must be more for girls. Okay, so there must be more girls than the boys. So I can choose only these options. Okay, either I can choose all the 4 of them are girls, or 3 of them are girls and 1 of them is a boy. Okay, so how I can write this in terms of combination? So therefore, here my total ways here is 10C0. Okay, so 10C0 into 8C4. So this is my first combination. That is, I can choose all of them 4 girls, none of the boys are chosen. Or when it comes to or, you remember the sign plus I said. So this is my first case, or it can be of my second case. What is my second case? That is 10C1 into 8C3. Okay, so out of 10 boys, I cannot choose any boys because all of the 4 are girls in my first case. In the second case, if I choose 3 girls out of 8 girls, I can choose only 1 boy. from 10 boys. So this is how I can write the total number of ways. Either the selection will be like this or like this. So now coming to the calculation, so we have 10C0. So remember the property of a combination, when it is NC0, it is 1, and when it is NC1, it is N. Okay, we'll use these properties. It will help for us for this calculation. So my 10C0 is 1 and 8C4 is 70. And my 10C1 is 10 and 8C3 is 56. So when you multiply, you will get 70 and 560. So therefore, it will be 630. So we can choose 4 members for the committee, whereas girls are in majority in 630 ways. Next question. From a class of 12 boys and 10 girls, 10 students are to be chosen for a competition which includes at least 4 boys and at least 4 girls. The 2 girls who won the prize last year should be included. In how many ways the selection can be made? So how many boys we have? We have 12 boys. Okay. And how many girls we have? We have 10 girls. So what we have to choose? We have to choose at least 4 boys or at least 4 girls. So this is my question, 4 girls. The 2 girls who won the prize last year should be included. So should be included. How many girls? 2 girls here. So here also I'll take -2. So we have only 8 girls now. Why? Because we have to remove the number of girls who are included. So in how many ways can the selection be made? So what do you mean by at least 4 boys? At least 4 boy means we can choose minimum 4 boys. So the rest of the thing are girls, 6. So 6 girls can be chosen. If I choose 5 boys, I can choose 5 girls. If I choose 6 boys, I can choose 4. I cannot go for 7. Why? Because we have at least 4 girls. At least 4 girls means minimum we can choose 4 girls, not less than that. So the last one is this. So we can choose 4 girls and 6 boys. So we have started with minimum of boys and we are end with minimum of girls. Okay. So this is the chance where we can choose boys and girls. Now how to write this in terms of combination? So this is my first selection or second selection or third selection. So since I'm using the word or, we can sum these combination. So how we will sum these combination? That is like this. So out of 12 boys, I can choose 4 boys, and out of 8 girls, I can choose 6 girls. Why 8 girls? Because the question says 2 girls must be included. Then this is my first case, or my second selection will be like this. So 12C5 into 8C5. Or my third selection will be like this. 12C6 into 8C4. So when you sum up this, what happens when you sum this? Now this is how we have done. So for this formation, I'll get 34,650. For this combination, I'll get 44,352. And for this calculation, I'll get 25,872. When you add all those things, I'll get 1,04,874. This is the number of ways we can choose the number of at least 4 boys and at least 4 girls for this question. So in this way, the selection can be made. Moving to my next question. A team of 11 is to be chosen out of 16 cricket players, of whom 4 are bowlers, 2 wicket keepers. In how many ways can the team be chosen so that there are exactly 3 bowlers and 1 wicket keeper? Question B, there are at least 3 bowlers and at least 1 wicket keeper. So what is my question? We have a team of 11. Okay. So out of them, 4 are bowlers. So we have 4 bowlers and 2 wicket keepers. So if 4 are bowlers and 2 are wicket keepers, that are 6, and remaining 7 will be other players. Okay, so 4 plus 2 plus 7, that is equal to 11. So we have a team of 11. And my first question, what does it states? There are exactly 3 bowlers and 1 wicket keeper. If we have exactly 3 bowlers and 1 wicket keeper, okay, so how many are left now? So we have 7 people. 3 plus 1 is 4. So how many members we can choose? 7. All the 7 we have to choose to form a team of 11. So how many players we have? We have 16 players. Out of 16 players, we have to make a team of 11, choosing 3 exact bowlers, 1 exact wicket keeper, and remaining other players. So therefore, 3 plus 1 is 4, 4 plus 7 will be 11. So now how I can write this in terms of combination? That is, out of 4 bowlers, I can choose 3 bowlers, and out of 2 wicket keepers, I can choose 1 wicket keeper, and I should choose all other players because no option left. So remember, one more property, NCN. So what is NCN? So it is always 1. So now what happens here? Also one more property I'll say, that is NCN minus 1 will be N. NCN minus N will be N. So 4C3 means 4, 2C1 means 2, 7C1 means 8, that is 8 is the answer. So we can make 8 selections. So let us start with 7th question. A team of 11 is to be chosen out of 16 cricket players, of whom 4 are bowlers and 2 wicket keepers. In how many ways can the team be chosen? So that there are exactly 3 bowlers and 1 wicket keeper. There are at least 3 bowlers and at least 1 wicket keeper. So we have 16 players in totals. So we have 16 players in total, but we have to choose only 11. Choose 11. But out of 16 players, we have 4 bowlers, 2 wicket keepers, and other 10s. Okay, my first question is, how the selection can be made if you choose exactly 3 bowler and 1 wicket keeper. So my total must be 11 for the team. So 3 plus 1 is 4. So all 7% should be choose from remaining 10 members. So how this selection can be made in terms of combination? So that is for my first question. So exactly 3 bowlers, 4C3, exactly 1 wicket keeper, that is 2C1, and remaining all others from other 10 members, that is 10C7. So total will be 11. Remember this property, you have NCN minus 1. So NCN minus 1 is N. So 4C3. This is in the form of NCN minus 1. So 4 and this is 2 and 10C7 is 120. So when you multiply, you will get this as 960. So in 960 ways, you can select to form a team of 11 members. Now let us move up for the question B. So there are at least 3 bowlers and at least 1 wicket keeper. So here the calculation is more. So since we have the word at least means we can choose 3, 4, 5. We can go, and at least 1 wicket keeper means we can choose either 1 wicket keeper or 2 wicket keeper. Since maximum we have 2 and here 4, we cannot go behind that. So we have 16 members. Choose 11 members. Okay, so 4 bowlers we have, 2 wicket keeper we have, and 10 others we have. Okay, my question was for this, at least 3 bowlers and at least 1 wicket keeper. So let me study all the chances here. So we have 4 bowlers, 2 wicket keepers, and 10 others. If I choose 3 bowlers and 1 wicket keeper. Then what about the remaining? So we will be having 7. If I choose 4 bowlers, that is maximum I can choose 4, minimum I can choose is 3. 4 bowlers, then again here also I have chances for 1 or 2. Let me put the chance for 1. 1 wicket keeper. Here it will be 6. Then moving on, if I keep again 3 particular bowlers and 2 wicket keepers, then here it is 6. Reaching the maximum, 4 bowlers and 2 wicket keepers, remaining here is 6. So these are the 4 chances I can get. So how to write this in terms of combination? We can write all these and we should sum up this. So how I'll write this? So 4C3, 2C1, 10C7. So 4C3 into 2C1 into 10C7. Next, 4C4 into 2C1 into 10C6. Next, 4C3, 2C2, 10C6. Next, 4C4, 2C2 into 10C5. So remember the properties here also. So whenever you have, I'll just write here, whenever you have n, c, n minus 1, your answer will be n. And when you have n, c, n, your answer will be 1. So the same property we will apply here. It helps for the simplification. So I'll just write the total after calculating this. So this is what I get: 960, 840, 420, 252. So when you add all these combinations, I'll get 2472. So these are the number of ways to select at least 3 bowlers, at least 1 wicket keeper and remaining others to form a team of 11. So moving to my next question. Out of 4 officers, 10 clerks, in an office, a committee consisting of 2 officers and 3 clerks is to be formed. In how many ways can this be done if? First question, any officer, any clerk can be included. Second question, one particular clerk must be on the committee. Third question, one particular officer cannot be on the committee. Now, let us look at here. We have 4 officers, 10 clerk. In a committee consisting 2 officers and 3 clerk is to be formed. Okay, so my selection is 2 officer. This is my selection. Okay, so and 3 clerk has to be formed. But we have a condition for the formation also. My first question is any officer, any clerk can be included. So there is, no restriction is there. So my answer is 4C2 into 10C3. Just calculate and find the answer. I'll just giving in terms of combination. Next, one particular clerk must be on the committee. Must be on the committee means this question says about including. So when you have to include any person, you have to remove that number of person from the selection as well as the total number. So one particular clerk. So here I'm talking about clerk. So one particular means minus 1. So therefore, my selection of clerk will be 9C2. Whereas in case of officer, there is no condition. So therefore, it will be 4C2 into 9C2. This is the number of ways to select in terms of combination. Moving on to the third question, one particular officer cannot be on the committee. Cannot be on the committee means here we are talking about excluding. So when it comes for excluding, you have to remove only from the total number. So therefore, and we have to select the remaining person from the remaining number. So we are removing 1 person or 1 officer from 4 officer. So we are left with 3 officer where 2 officers must be chosen and clerk will be same, that is 10C3. So these are the ways to calculate to the given question. My next question. A candidate is required to answer 6 out of 12 questions, which are divided into 2 groups containing 6 questions. In each group, find the number of choices he has if he cannot attempt more than 5 questions from group A. Consider an example. Suppose you have part A and part B in your question paper. Okay. Part A contains 6 questions, part B contains 6 questions. So you have to answer at least 6 questions from these two. But one particular question should be answered in both parts, that is part A and part B, but in total you have to answer any 6 questions from part A and part B. How this can be done? Okay, so this is my question. If I answer only one question in part A, I have to answer all the 5 questions in part B. If I answer only 2 questions in part A, I have to answer 4 questions in part B. If I answer 3 here, then I have to answer 3 because my option is to answer only 6 questions out of 12 questions. So 4 here, then 2 here, 5 here, then 1 here. We cannot take 0 because it is not possible. One particular question must be attended from part A and part B. So these are the options I have left with. So options are nothing but these number of cases I have for selection. Okay, so how I will write in terms of combination? So just look at it. So as I said, this is part A, part B. We have 6 questions each. So I can answer 1, 2, 3, 4, 5 questions. I cannot answer all the questions. So here I have the choices 5, 4, 3, 2, 1. So coming to the combination here, how will be my cases here? So here my first case is 6C1 into 6C5. This is my first case, and my second case here 6C2 into 6C4. Next my third case 6C3 into 6C3. My fourth case 6C4 into 6C2. And my fifth case 6C5 into 6C1. So these are the possibilities of choosing or answering the questions. So here also for calculation simple, NC1 is N, NC1 is N, NC, N minus 1 is also N, and suppose if you have NCN, it is 1. Remember these simple properties. So I'll just write the calculation part and I'll write the total number of selections. So this is about the calculation. We have got 36, 225, 400, 225, 36. So total 922. So in 922 ways, he can answer any questions. That is, in total, he has to answer 6 questions out of 12 questions, where 6 from part A and 6 from part B. Next question. A man has 10 relatives, 4 of them are ladies, 3 gentlemen and 3 children. In how many ways can he invite 7 relatives to a dinner party so that there are exactly 2 ladies, 3 gentlemen and 2 children? There are exactly 2 gentlemen, at least 3 ladies. So let me solve for the first question. So total we have 10 relatives, out of which 4 ladies, 3 gentlemen and 3 children. My first question is, there are exactly 2 ladies. He has to invite exactly 2 ladies, exactly 3 gentlemen and 2 children. So what will be my combination for this? That is 4C2 into 3C3 into 3C2 into 3C2. And what about my second question here? There are exactly 2 gentlemen, at least 3 ladies. So when you have these kind of questions, see here we have 4 ladies. This is for question B, 3 gentlemen and 3 children. So we have exactly 2 gentlemen. So let me fill it first. 2 gentlemen is compulsory. At least 3 ladies means either he can invite 3 ladies or he can invite 4 ladies. So therefore, what about the children here? Out of 10, we have to invite 7. So 7. So therefore 3 plus 2 is 5. I can invite 2 children. If here is 4, gentlemen is exactly 2 as in the question. So 4 plus 2 is 6. So here I have left with 1. So what is my cases here? How I can write this? First case is this one. Second case is this one. So my first case is 4C3 into 3C2 into 3C2. And my second case is 4C4, 3C2, 3C1. So I'll just write the calculation part now. Yes, this is now. So we have 36 and 9 here. So what about the total number of ways? Just add it. That is 36 plus 9 is equal to 45. Now, so this is how we can select. See, what is the question given? Out of 10 relatives, he has to invite 7 relatives. And my first question is, he has to invite 2 ladies, 3 gentlemen and 2 children. So that is exact number. So therefore, my combination will be like this. That is 4C2, 3C3 and 3C2. Whereas in the second case, 2 gentlemen can be invited, but exactly 3 ladies they have not given. They have given at least 3 ladies. Means I have the chances to invite either 3 or 4. So therefore, it may be 4C3 or 4C4. So since 2 gentlemen are exact, so it is 3C2 in 3C2 in both the cases. But number of children varies according to the total to form 7 relatives. So therefore, my combination for the first one is 36 and 9. So my total ways of inviting 7 relatives out of 10 relatives will be 45. So this is how we will form or arrange or select number of people to combine a particular type of question. Okay. So when you have at least a type of problem, you should think that at least means minimum number you can choose. Suppose you have 5 girls, you are supposed to choose only 3 girls, then your cases will increase. You can choose 3 girls, 4 girls or 5 girls. Like that. If you have boys, 6 boys, and you are supposed to choose 4 boys. Okay, so then at least when it comes at least to 4 boys, you can choose 4 boys or 5 boys or 6 boys. So maximum you can 6 boys. So this is how we will be. And coming to included property, or when you have 10 members, you have to select 8 members and include 2. Then this will change. It will change to 8C6. Okay. When it's come for excluded type, the same question I'll say. When you have 10 members, you have to select 8 and exclude 2. That means you have to remove the person. So your combination selection will change to 8C8. Okay. Why? Because 2 person cannot be included. Cannot be included is nothing but they are not in team. So therefore, we have to remove them and we have to form a selection. So these type of question we have discussed today. So I hope you all enjoyed today's class. So there will be slight mistakes while doing calculation, but make sure the combination or the selection which you will choose out of these questions must be perfect for the calculation. So this is all about today's session. So we have learned in detail about permutation and combination, and this is the last session. That is, we have dealt with the problems of combinations and its arrangement. So I hope you all studied and watched my previous videos. So we'll meet you in the next class. Until then, keep watching, keep learning and keep exploring. Thank you.